our country will consume more energy than it has in its entire history. Yet the kinds of energy we use today are becoming difficult to get, dangerous, and destructive to the Earth.
An AEC spokesman says scientists have discovered a factor which might narrow the safety margin in case of
Until recently, there has been very little effort or money given to developing various new sources that are clean and that can provide energy for centuries to come. One possibility is converting waste into energy. In St. Louis, shredded trash provides 10% of the fuel for a power plant. Trash can also be converted into methane, a combustible gas that can be used as a fuel. Here, at a covered landfill site, methane is produced naturally from decomposing trash and is simply burned off. Methane can also be produced from animal manure. It is estimated enough methane could be produced from a large feedlot to supply the natural gas needs of a town of 15,000 people. Changes in the tide can be used as a power source. Here in France, the tides flowing in and out of an enclosed basin are used to generate electricity. However, large tides like this occur in only one place in North America. There are proposals for using the temperature differences in the ocean to run a heat engine. The best place would be the Gulf Stream, where large temperature differences occur between the surface and deeper water. For a long time, wind has been used on farms to pump water and produce electricity. In the early 40s, this wind generator with huge 90-foot blades produced electricity for a while on a hill in Vermont. It has been suggested that significant amounts of energy could be produced by enormous wind generators placed off the New England coast in the constant ocean winds. One large potential source is geothermal energy, the natural heat of the Earth. It has been used for many years in other parts of the world. There is only one geothermal power plant in the United States. Here, steam from underground reservoirs turns a turbo generator in a power plant. There are many other possible locations for geothermal plants, particularly in the West. Beneath this farmland in the Imperial Valley and running across into Mexico is a huge reservoir of hot water. In certain places, as at this well area discovered by Dr. Robert Rex, the water rises close enough to the surface to be tapped.
This literally gives you many cubic miles of water in storage, perhaps the order of 40 cubic miles of hot water in storage. And this makes the enormous reserve of geothermal energy in this valley that really looks, from the figures we have today, as though it could maintain sustained production of 30,000 megawatts of electrical energy for a long period of time, probably the order of half a century to a century at least. And that's a real minimum figure, we think.
30,000 megawatts would be enough electricity to supply all of California's needs in the mid-1970s. South of Mesa Well, near an inactive volcano, Mexico has already built a geothermal power plant which uses this hot water.
problemas, por ejemplo, en este campo ha sido que se obtiene agua caliente y no vapor, entonces hay necesidad de utilizar separadores de agua y con el consiguiente problema de qué hacer con esa agua.
There is no technology that is free of environmental impact. Geothermal wastewater often contains mineral salts, which could cause serious problems if they get into drinking or irrigation water. The noise, the gases released, and the land area taken up by the plants are other problems that must be dealt with. However, the problems in many areas may be less than those of other sources of energy.
Geothermal energy is where you find it. And the most economic to develop geothermal energy occurs in the western United States. The next area that will develop is the Gulf Coast. And certainly a larger investment of public funds in geothermal research would accelerate the development of the geothermal potential, say, of the northeastern U.S. Because in the Appalachians in the northeastern part of the country, we're going to have to drill a lot deeper. Wells will have to go to 18,000 feet, and we won't find natural steam because the rocks will be so dry. We'll have to find ways of fracturing the rock, passing hot water through the hot rock, and recovering the thermal energy in this way.
With the cost of fossil fuels increasing and pollution from them becoming a problem, geothermal power is an important energy alternative that we must develop. In the past 25 years, government and industry have put billions of dollars into developing just one new energy source, nuclear fission power. Yet nuclear fission plants produce large quantities of radioactive wastes and are potentially the most dangerous of all our sources of energy. While nuclear fission plants work by splitting uranium atoms apart, there is another nuclear process, nuclear fusion, which works by fusing atoms together. This is the process that takes place in the sun and in the hydrogen bomb. For power generation, fusion would be much safer than fission, but there are many difficult problems that remain to be solved.
What you're seeing here is a very large and very complicated looking experiment aimed toward trying to solve the problem of nuclear fusion. Inside of this very large pan is a magnet coil which is refrigerated down to the temperature of liquid helium. That's almost absolute zero. What we're trying to do is to hold inside of this magnetic field a hot plasma, a very hot gas of deuterium, which would react and make nuclear reactions if we can be successful.
If controlled fusion power becomes possible, its fuel will be plentiful. Seawater contains a kind of hydrogen that would be used in a fusion power plant.
The amount of heavy hydrogen in this little bottle might cost a few dollars at today's prices, but if burned in a nuclear fusion reactor, would make enough energy to supply your home with electricity for almost 100 years. By contrast, it would require hundreds of tons of coal to supply your home with that same amount of electricity for the same period of time. Over a period of years, I think many people feel that fusion is about the only, with one possible other exception, power that one could really call the ultimate source of power. The other one is solar energy, which might be a power also to be used in the future. But beyond that, we know that we will not be burning oil. We know that we would prefer not to rely on uranium power indefinitely because of its problems, environmental problems. We know that coal, even though it is a very large supply, eventually will be exhausted, and we know it causes pollution.
Fusion has great promise, but we do not know when or if it will be successful. Even if it can be proven in a laboratory, it will be very difficult to build a fusion power plant. However, some scientists, such as Dr. Post, believe that with the CRASH program, we might begin to have electricity from fusion before the year 2000. The sunlight, falling daily on 1% of our land, has more energy than all the coal, oil, and gas we burn each day. It is a source of energy that would last us forever. Yet because the sun's rays are diffuse, solar energy has to be collected and concentrated, and it must be stored for periods when there is no sun. One way of using the sun's energy is by solar cells. These cells transform the sun's energy directly into electricity, here enough to power a television. Today, solar cells are used only for specialized purposes, such as providing the electricity for this space satellite. They are individually made and expensive. However, there's never been a serious effort to learn how to mass produce them. If the costs were brought down, they might become a major source of electricity. There are other ways to get useful energy from the sun.
The energy from the sun is very fragile. There's, like a day like today, we're hardly collecting any energy at all. So we've got to be able to use the little bit of energy we get very efficiently. We're not using the energy we have, whether it's fossil fuels or wind or solar, we're not using them really efficiently, and we have to use the energy efficiently. Okay, especially if we get it from the sun and the wind.
Robert Reines has designed and built his home as part of an energy-efficient system. He uses the sun to heat his home and provide hot water. In his system, sunlight heats water which flows through tubing in collector boxes. For periods of cloudy weather, the hot water is stored in an insulated tank. The water is circulated through baseboard registers for heating. His energy system is completed by wind generators which provide electricity.
This whole problem here is reaching for the ideal. Ideally, you would like to power, the universe with energy which makes sense in terms of anybody on spaceship Earth can use it, provided they're where the energy exists. A little difficult in the North and South Poles. It should be inexpensive so people can use it. And you stand out here and people say, well, I'd like to put a solar heating system on my house. You say, well, how much clouds do you have? Where are you? How much sun do you have? They seem to forget that. They seem to think that solar energy is a black box and you just bolt some solar heating equipment onto a house and start heating it. In fact, this isn't true. There are only about 20 or 30 solar heated houses in the world. This is the only one that's totally solar heated. And suddenly, because solar energy seems like it might be an answer, everybody's jumping on the bandwagon is going to do a solar heated house. And it's not easy. To get simple things is very complicated.
This building demonstrates how solar technology can be applied to more conventional buildings. It has not only a solar heating system, but also solar air conditioning run from these panels. In many parts of the world, solar panels are being used not for heating rooms, but as hot water heaters. In this country, solar water heaters could save large quantities of fuel.
A large set of collectors in this roof area, for example, would remove 80% of the natural gas requirements for water heating in this building, and those gas requirements are the largest single energy use in a building like this. Those solar water heaters would essentially preheat the water so that instead of cold city water going into a gas water heater, you have preheated or solar heated water, and you've saved a lot of fuel. The economic question is, can the fuel savings over a 10 or 15 year period match the additional cost of building and installing and maintaining these solar collectors on the rooftop? With the cost of natural gas going up, we expect systems that supply hot water in this way will in fact be competitive before the end of this decade.
The construction industry is very slow to accept changes. If solar panels are to become widely used on buildings, we will first have to develop commercial models that can be mass-produced. If we make the effort, some experts believe that by 1985, 10% of all new buildings could have solar panels. Large electric power plants could also be run on solar energy.
If you took a square here 70 miles by 70 miles out of the desert somewhere, for example, that would have a sufficient energy coming in there from the sun to power the entire United States. in the year 2000. Give it all of its electrical power. Now, we're not proposing you take 70 miles square in one area and just cover it solid with these solar power farms, but I think you can see that if you, again, put them around different parts of the country, the area is quite small.
Dr. Meinel plans to use sunlight to run a steam power plant. The top of his collectors are lenses which focus the sunlight onto pipes. The heated fluid in the pipes is carried back to storage tanks where it is used to produce steam. Storage might be in molten salt, but there are other possibilities.
Instead of having all of the energy in storage as molten salt, there may be times that you would want other forms of chemical storage. So the suggestion has been, why not take some of the excess energy in summer, because the days are longer, and convert that into a storable fuel, say liquid hydrogen or something like that, and then use that hydrogen to operate the power plant when you get low with your other sources of energy. And after all, that hydrogen may be very useful because automobiles and airplanes and other things will probably run on hydrogen in the future as gasoline and other fossil fuels become scarce.
With an early model of his collector, Dr. Meinel demonstrated that solar energy could be used to run a power plant. The pipe in the collector was covered with special thin film coatings which trapped most of the sun's heat.
Some of the contributions done here by our staff at the university have now made these films so selective that we can almost begin to use them on cloudy days as well as sunny days, and that is our ultimate goal, because we'd like to be insensitive to the weather. After all, we in the Southwest have lots of sunshine, but most of the country has much more cloudy weather than we do in the Southwest. So to make solar energy practical to the rest of the United States, you either have to develop the technology for distributing the power long distances, or a type of collector that will operate with the bright, cloudy skies.
If we'd had the foresight 20 years ago to develop solar power, perhaps we might have it today. If we make the effort now, we can have it before another 20 years is gone.
Eventually, to develop solar power to a point where it can really be considered to have arrived would require an investment of the order of $1 or $2 billion in the next 10 years. The severity of the energy crisis probably makes it such that this will, in fact, be done if the studies such as the small model we have here and the small prototype are successful. They will inevitably follow, because it is a very important potential option for new power sources.
All alternative energy sources will take a lot of money and effort. We must work on each of them so that in the future we will have a variety of options from which to choose. Because in the past, the federal government concentrated on the development of only one new source, nuclear fission power, today we find ourselves with just one operating geothermal plant, fusion power far off in the future, and the sun's enormous energy still untapped. If we are going to have sufficient clean energy in the future, we will have to start